let's talk about building AI. You know, we're moving past that chaotic, let's just see what happens kind of coding. Today, we're diving deep into the professional way to do it. We're talking about architecting for real scale and reliability, and we're going to do it all inside Google's powerhouse ecosystem.
Look, we've all done it, right? Just kind of throwing prompts at a model, crossing our fingers and hoping something good comes out. And yeah, it can be fun for a bit, but let's be real, it's a total recipe for disaster. Unpredictable results, endless debugging. Sound familiar? So today, we're shifting gears. We're talking about a structured, methodical process. This is how you take those brilliant ideas and turn them into AI apps that are actually scalable and, reliable.
So here's the game plan. We're going to start with the Spec-Driven Blueprint, then craft a prompt that actually does something, walk through a 4-stage building method called S.H.I.P, and we'll even get into building autonomous agents. And the best part? It's all happening inside Google's integrated AI stack. All right, let's kick things off with the blueprint. I mean, every great application has to start with a solid plan, right? We're going to look at how you go from just a fuzzy idea to a detailed, actionable spec that becomes the rock-solid foundation for everything that comes next. Okay, this right here, this is a huge shift in thinking. You know, in the old days, a spec was just a map, a guide, something people could interpret differently. But with Spec-Driven Development, or SDD, the spec isn't the map anymore, it's the engine. That's the core idea. By making our specifications accessible, we get rid of all that guesswork and make sure the AI builds exactly what we want. And this workflow? It's just brilliant. So first, we cast a super wide net with Gemini Deep Research. We let it go out and just absorb everything it can about the market, the competition, you name it. Then, we take all that amazing insight, plus our own internal docs, and we pour it all into NotebookLM. This is where the magic happens. We synthesize everything and create what I call a living specification, a single source of truth for the whole project, totally grounded in real data.
Okay, so we've got our spec. It's our single source of truth. Awesome. But now what? How do we take this document that we humans understand and turn it into something an AI can follow without messing it up? Well, that's exactly where the Product Requirements Prompt, or PRP, comes into play.
But before we get to the PRP, let's talk about a really cool tool in our toolbox, Gemini Gems. Seriously, just think of a gem as your own custom-trained AI specialist. It's like you can hire an expert for your team. You can feed it your entire API documentation, tell it to act like a senior staff engineer, and boom, you have an expert on your project before a single line of code is even written. And this is where all clicks into place. We take that entire living spec we created and distill it down into one master instruction set, the Product Requirements Prompt. And I want to be super clear, this is not just some simple one-line prompt. It's a comprehensive, highly structured, executable blueprint. It tells the AI literally everything it needs to know to build your app from the ground up.
So you're probably wondering, how on earth do I create a prompt that detailed? Well, we don't have to do it from scratch. We use something called a meta prompt workflow. Basically, we use one of those custom Gemini gems we just talked about, but we train it to be an expert product coach. It then literally interviews you. It'll ask all the important questions. Who is this for? What's the main thing it does? What should it feel like? And then it takes all your answers and magically structures them into that perfect, comprehensive PRP for you.
All right, we've got our spec, we've got our executable prompt. Now it's time for the fun part, the build. And to make sure this goes smoothly and predictably, we're going to follow a super reliable 4-stage lifecycle. It's called the S.H.I.P method. So, S.H.I.P. It's simple. Systems planning, handpicked tools, initial test build, and production build. It's just a straightforward, repeatable framework to get you from an idea all the way to a deployed app. Let's break down each part. First up is S for systems planning. Think of this as the 30,000-foot view. Before we let the AI even think about writing code, we have to put on our architect hats. Our job is to map out the big, structural pieces of the application. This is where we jump back into NotebookLM to pull our thoughts together and just list out the major components. Do we need user logins, a database? What about some kind of AI integration? Again, we're not talking about code yet. The whole point here is to just get a clear, simple list of the systems we're going to need.
Next, we've got H for handpick your tools. And listen, this is a step you absolutely cannot skip, even though a lot of people do. Remember, you are the architect here. It's your job to make smart, informed decisions about the tech stack. Don't just blindly accept whatever the AI suggests first.
This is where you use Gemini and Google AI Studio like your own personal expert consultant. Seriously, make different services compete. Ask it things like, hey, in plain English, compare Firestore versus Cloud SQL for my app. The goal is to walk away from this stage with a final, decided-upon list of technologies for your app. No more guessing.
Okay, now for I, the initial test build. I gotta say, I love this part. The motto here is simple, ugly but functional. We are not trying to build the final, polished product, not even close. The only goal is to build the quickest, dirtiest version possible to see if our main idea actually works.
It's all about speed in this phase. We take our big PRP, feed it into something like Gemini Canvas, and let it spit out a fast, interactive prototype. All we care about is answering one question. Does the core logic hold up? If the answer is yes, then great. This prototype did its job, and we can literally just throw it away and move on.
And that brings us to the final step, P for production build. So at this point, our main idea is validated, we've handpicked our tech stack. Now, and only now, do we start fresh with a totally clean slate to build the real deal, the final, robust, scalable application. This is where Firebase Studio becomes your command center. You're not just coding alone, you're working with the integrated Gemini agent as your partner. You guide it to generate code, write tests, squash bugs, and then you can deploy your app directly from that same interface. It's incredibly powerful.
And hey, once you get this whole structured workflow down, you can start applying these same exact principles to even more advanced stuff. I'm talking about building fully autonomous agents.
And the architecture for these agents is actually, well, it's beautifully simple. You basically have two parts. There's the planner, which is the brain. That's a powerful Gemini model that takes a big goal and breaks it down into small, logical steps. Then you have the tool library, which are the hands. These are a bunch of cloud functions that can perform specific real-world actions. So the planner decides what to do, and the tool library goes out and actually does it.
So when you put it all together, what you have is a complete end-to-end system. The point is, Google gives you this incredibly integrated set of tools that lets you go smoothly from just a vague idea all the way to a researched, specified, and deployed AI app. And you can do it all using a structured, repeatable, and frankly, powerful workflow.
You know, at the end of the day, this whole structured approach, it's not just about building faster. It's about building smarter. It's about building more reliable and, honestly, more ambitious AI products. All the tools are right here, the workflow is clear, and really, that just leaves us with one very exciting question to think about.
All right, welcome back. In our last explainer, we talked about that initial, almost chaotic phase of just getting an idea out there. But today we're gonna level up. We're moving beyond vibe coding to something way more disciplined. We're talking about building real, predictable, enterprise-grade AI apps. And the key to all of this is a methodology called Spec-Driven Development, especially when you're working inside the Google AI and Firebase ecosystem. Okay, so here's what we've got on deck. First, we're going to talk about a new source of truth, what that even means. Then we'll break down the 4 phases of this whole SSD thing. After that, and this is the really practical part, we'll look at the specific Google tools you can use for each phase, and we'll wrap up with why this approach gives you a massive advantage. All right, let's dive right in. Section 1, a new source of truth. And that subtitle says it all, from temporary guide to executable engine. See, Spec-Driven Development, or SDD for short, it's not just some small tweak to how you work. It is a complete, fundamental shift in how we should think about building with AI. It's all about changing what a spec actually is. And this quote, man, this really nails it. Think about it. We've all been there, right? You write up a spec, it's this temporary guide, and by the time you start coding, it's already out of date. SDD completely flips that on its head. The spec isn't just a suggestion anymore. It becomes the executable source of truth. It's not just a guide, it's the actual engine that drives the whole implementation. So what does this actually mean in practice? What's the definition here? Well, it's a disciplined methodology, and that word disciplined is key. The spec becomes the source of truth that directly generates the implementation. We're literally engineering the ambiguity and the guesswork out of the process. You get this reliable, predictable workflow where every piece of code the AI writes can be traced right back to a requirement you wrote. No more mystery. And this chart just lays it all out, the before and after. The traditional way, it's like this. Speculative conversation. You're just kind of hoping the AI gets what you mean, and you end up reacting to whatever it spits out. But with a spec-driven workflow, It's a structured collaboration. The spec is the boss. And that means you're no longer reacting. You are directing. You're in control, making sure the output is exactly what you intended. You're in the driver's seat, plain and simple. Okay, so that's the big idea. But how do we actually do it, right? How do we put this into practice? Well, that's where the 4 phases of SDSCD come in. Think of this as the structured blueprint for how you and the AI are going to work together to build something amazing. And here they are, super simple. Specify, plan, tasks, and implement. It's a really logical flow, right? You go from the big picture vision all the way down to the code that makes it happen. Let's break each of these down a little more. So phase 1, specify. This is where you're the strategist. You're the visionary. Notice we're not talking about code at all yet. This is all about the what and the why. What are we building? Why does it matter to the user? What are the business goals? You're laying the foundation, the bedrock for everything that comes next. Okay, next up, phase 2, plan. Now you switch hats. You take off the strategist hat and put on your architect hat. This is where we figure out the how. What's the tech stack? What's the architecture going to look like? These decisions are super important because they become the guardrails for the AI. You're telling it, okay, build it, but build it inside these lines. Then we get to phase 3, tasks. And this is all about getting super, super granular. You take that big architectural plan and you break it down into a tiny step-by-step checklist. It's like writing a recipe for the AI. Each step has to be totally clear, totally actionable, so there's no room for misinterpretation. This is where you really get that fine-grained control. And finally, phase 4, implement. And listen, this is not the part where you just press a button and walk away. It's not fire and forget. It's a dance. The AI executes a task from your list, it writes some code, and then you, the developer, step in to verify it. You check the work. You're in this constant interactive loop, making sure everything is perfect. You're always the one in charge. Okay, so this all sounds great in theory, but what about the real world? What tools do we actually use? Well, the beauty of this whole thing is that this entire 4-phase methodology maps perfectly onto the Google AI tools you probably already know and love. So here's the toolkit in a nutshell. Look at this. For phase 1, specify. You're using Gemini Deep Research and NotebookLM. For phases 2 and 3, plan and tasks. It's all happening in Google AI Studio. And then for the final implementation phase, you're bringing in Firebase Studio alongside Google AI Studio. It's a complete end-to-end workflow. So let's zoom in on that first phase, specify. You're going to start with Gemini Deep Research to do all the heavy lifting, market research, discovery, you name it. Then you take all those insights, plus all your internal docs, and you pull them into NotebookLM. NotebookLM becomes your single source of truth, the place where you synthesize it all and actually write that killer executable spec. Now for planning and tasks, your main playground is going to be Google AI Studio. Seriously, think of it as your AI-powered workbench for all the technical design. This is where you take that spec we just made in NotebookLM and you start crafting these detailed prompts that basically define your entire architecture. And then, right there in the same tool, you break it all down into that actionable task list. And then it's time to build. For the implementation phase, Firebase Studio is your workhorse. It's your main AI coding agent that's going to generate the bulk of the application. But you'll also keep Google AI Studio open because it's perfect for generating smaller code snippets and specific building blocks from your task list. And just to say it one more time, your job here is absolutely critical. You guide, you correct, and you verify everything. You have the final say. All right, let's bring it all home. The spec-driven advantage. Why does any of this matter? Why go through all this trouble instead of just winging it? For anyone doing serious professional AI development, the payoff is huge, and it really boils down to 4 things. So here it is. First, you get predictability. No more guessing, no more vibe coding. Second, you get reliability. You can be confident that what you build is actually what you set out to build. Third, verifiability. You can trace every line of code back to a requirement. No more black boxes. And most important of all, you get control. You, the developer, are empowered. You are the ultimate authority. This is the real deal, folks. This is what professional AI development looks like. So I'll just leave you with this one question to think about for your own work. Is your spec just a conversation starter? Or is it truly ready to be the engine that drives your next application? Really think about that. Thanks so much for watching, and we'll see you in the next explainer.
Welcome back.
In our last couple of sessions, we went from the free-flowing concept of vibe coding all the way to the structured approach of spec-driven development. Well, today, we're going to push that idea even further. I want you to think about something. What if your spec wasn't just a guide for development? What if your spec was the development?
Seriously, just think about that for a second. Imagine a workflow where your product requirements document isn't just for a human to read. Imagine it's an executable blueprint that an AI can take, understand, build from, and even deploy. That's not science fiction. That's exactly what we're breaking down today.
And this is how we do it. It's called the Product Requirements Prompt Workflow, or PRP for short. It's a 5-phase system, a really elegant loop that's designed to take you from a fuzzy idea in your head to a real, functional AI-generated prototype, all inside one integrated ecosystem. So, let's dive in and see how it works.
Okay, so the first couple of phases are all about one thing: getting to absolute, undeniable clarity. The whole goal here is to take that idea you have and forge it into a concrete, machine-readable contract, one that leaves absolutely no room for guessing. This is really where the process starts to feel like magic.
And it all begins not with a single line of code, but with a conversation. A deep, structured conversation. We call this the meta-prompt phase. You can think of it as a brainstorming session, but, on steroids. You're not just writing specs alone. You're co-creating them with an AI partner that's actually pushing you to think deeper.
So in this phase, you have a powerful model, like Gemini, playing the role of your personal AI systems architect. Let's say we're building our example project, CowCub. The AI is going to ask you these really probing questions. Not just the basics like, what should it do? But stuff like, what are the edge cases for user input? How should errors be handled? It's designed to help you articulate every single part of your idea, especially the parts you haven't even thought of yet.
And the result of that conversation is beautiful. The AI can reflect back the core logic to you, just like this. It helps you find those hidden ambiguities and really solidify the entire conceptual framework of your project. You and the AI get perfectly aligned before anyone even thinks about writing code. It's a real partnership in clarity.
So now we take that incredibly productive conversation and turn it into a binding contract. All those insights from the meta prompt get formalized into what we call the Product Requirements Prompt, or the PRP. And this isn't just a simple summary. It is a detailed, structured, multi-part document that becomes the absolute single source of truth for the AI.
You'll build this PRP out in a tool like Google AI Studio, and it becomes the master instruction set. I mean, just look at how a feature like the login system is broken down here. It has a crystal clear description, it lists the specific inputs it expects, and it defines the exact outputs. This is that unambiguous blueprint we were talking about, and it ensures the AI knows exactly what to build.
All right, so we have our rock-solid blueprint in hand. It's clear, it's detailed, it's unambiguous. Now we can confidently move from the planning stage into actual execution. And from here on out, every single phase is going to build directly on this amazing foundation we've just created.
We're now in the implementation phase. This is where that blueprint finally comes to life. It's pretty straightforward. You take your meticulously crafted PRP, you feed it directly to Gemini right inside Google AI Studio, and you tell it to generate the core files for our CalcHub prototype.
And just like that, the AI starts building. It spits out the initial HTML, the CSS, the JavaScript, bringing that structure to life. But here's the cool part. This isn't a one-and-done thing. As your project gets more complex, you don't start over. You just add incremental instructions based on your PRP, building out new features piece by piece, all while maintaining that continuous conversation with the AI.
Now look, no first draft is ever perfect, right? You're absolutely going to run into bugs. But in this workflow, you are not debugging alone. The AI literally becomes your collaborative debugging partner.
So instead of spending hours staring at a screen, trying to find a missing comma or a typo, you can just leverage the AI's analytical power. The whole process is incredibly simple and, well, really, really efficient.
So first step, you just find the piece of code that's giving you trouble and you copy it. You don't have to explain the whole app, just the bit that's broken.
Next, and this is key, you give it the exact error message that you're seeing in your developer console. That context is what allows the AI to really understand what's going wrong.
And boom, here's the result. The AI analyzes the code, it looks at the error, it finds the bug, and it gives you the corrected code back, usually with a super clear explanation of what went wrong and why. This just completely changes the game for debugging. It turns what could be a major roadblock into a tiny little speed bump.
Okay, so our prototype is working, we've debugged it, it's functional, it's ready to go. The last step on this journey is to actually push it out into the world and make it accessible to everyone.
And this brings us to the deployment phase. We take our working application and we use the power of the Google ecosystem to get it live. Our tool of choice here is Firebase, which, as you might guess, integrates perfectly into this workflow. Whether you use the Firebase command line tools or the web console, you can deploy your application to Firebase hosting. And in just a few moments, this whole complex journey, from a simple idea to a detailed prompt to generated code, it all culminates in this one live, shareable web application. Our Calc Hub is now real.
So let's just pull back for a second and look at the whole picture. This isn't just a list of disconnected steps. What we have here is a powerful, repeatable development loop, and it's all powered by a set of tools that are designed to work together perfectly. Think about how this all connects. The meta prompt, that initial deep conversation, that happens with a model like Gemini. The PRP creation, the implementation, and all the debugging, that all lives inside Google AI Studio. And then the final deployment is handled seamlessly by Firebase. It's a truly cohesive system that guides your project all the way from concept to code and finally to the cloud. And that really brings us to a final, pretty big question. This workflow, it represents a fundamental shift in how we build things. We're moving away from a world where we focus on writing thousands of lines of code to a world where we architect high-quality conversations and incredibly detailed prompts. This really redefines what it even means to be a developer or an architect. What do you think that future looks like? Thanks for joining me.
Welcome back to our final explainer in this series on building with Google AI. So far, we've looked at some really powerful methods like Spec-Driven Development and the S.H.I.P method. But today, we're going to tie it all together. We're unveiling the one key that unlocks the full power of everything we've talked about. All right, here's the plan. We'll start by revealing the single concept that connects everything. STD, PRP, S.H.I.P, the whole lot. Then I'll introduce you to the perfect tool for it. We'll see it in action, and finally, we'll talk about why this is a total game changer for AI development. Okay, let's dive right in. All those frameworks we've covered, they're actually just different flavors of one crucial discipline. And that secret is something called context engineering. So what is it? Well, it's all about building the entire kitchen for the AI to work in. We're not just handing it a single recipe, a prompt, and hoping for the best. No, we're providing the tools, the ingredients, the rules, the whole setup to guarantee a great result. But that leads to a huge problem, right? Manually creating that perfect context for every single task is really difficult. It's time-consuming, it's super prone to error. This is the big scalability problem we absolutely have to solve if we want to do this right. And this is where Google's solution just brilliantly comes into play. Gemini Gems. They are purpose-built to codify, to centralize, and to reuse all that expert context we've been talking about. You gotta think of a gem as more than just custom instructions. It's like a container for your team's best practices, your rules, your knowledge, all of it, packaged up and ready to be deployed in an instant. So what's actually inside one of these? Well, first you've got the instructions. This is the persona, the goal, the core task for the AI. Then there's the knowledge base. This is your source material, your documentation, your style guides, maybe even old proposals that worked really well. And finally, you have the rules and constraints. These are the non-negotiables, the guardrails the AI absolutely must follow. These three things working together, that's how you pre-engineer the perfect context. Okay, let's move on to some examples and see how this actually builds on the frameworks from our previous explainers. This is where it gets really practical. For methods like spec-driven development, Gems provide that layer of consistency that turns what was a manual process into a genuinely automated system. You can codify your project principles right from your constitution.md. You can generate structured artifacts and enforce total consistency. For example, you could create a project standards gem. You define the rules right in the instructions, like all web apps must use Next.js. You upload your required code templates and style guides as its knowledge. Then, you just prompt the gem to create a new feature spec. And what you get back is a standardized output, documentation that perfectly follows every single one of your rules. And this isn't just for SDD. Remember the product requirements prompt, or PRP? while a meta-prompt gem can be designed to systematically walk a user through all those crucial clarification questions, making sure you end up with a really robust final prompt. All right, now let's see how Gems can automate the really high-level strategic planning that's required by the S.H.I.P method when you're building out Google AI apps. So, for the systems planning phase, you can build this magic phrase directly into a Gems instructions. You're literally defining its persona as an architect who has to speak in plain English. This is a huge deal because it makes complex technical decisions accessible to everyone, not just the senior engineers. And for the handpick your tools phase, check this out. You can load a gem up with all the official Firebase documentation. Then it can generate a comparison matrix just like this one. This makes sure your architectural decisions are grounded in actual facts, not just whatever the AI happened to suggest first. And to wrap it up, you can have a production build plan gem. This one takes your validated concept and spits out the final, detailed, multi-phased implementation plan. It's a blueprint that's totally ready to be handed off to an AI coding environment like Google AI Studio. So here's the crucial point. When you master context engineering with Gems, you gain these really significant strategic advantages. It's way more than just writing better prompts. You get 4 key benefits. 1, enforcing consistency, so every output meets the same standard. 2, centralizing rules, creating a single source of truth. 3, grounding outputs, so AI responses are based on your knowledge. And 4, scaling expertise, which lets your junior team members tap into senior-level knowledge. These benefits are what turn development from being inconsistent and artisanal into something standardized, scalable, and seriously reliable. And that leaves us with a final thought to chew on. As AI gets more and more capable, the highest leverage skill might shift from just writing clever one-off instructions to actually engineering these reusable expert systems. So, crafting the gem might just become more valuable than crafting the prompt. What do you think?